So we're going to do an example where we start blending our use of technology with our knowledge of calculus. In particular, we're going to work with the graph of 4 sine x plus cotangent of x in the interval negative pi to pi. So that's kind of giving you your window setting in the x direction. But let's first plug in the function. Now when you're plugging in the function into your calculator, you might be looking for that cotangent button. It is not tan to the negative first. What's tan to the negative first going to give you? The inverse tangent or the arctangent, depending on the language you want to use for that. But it's one of the two. It's not the cotangent. Beyond that, we're going to need a couple derivatives. So you can actually calculate the derivatives here. That's fine. It's pretty straightforward. But in as much as you're not always going to be able to calculate the derivatives, let's remind ourselves as to what our calculator is going to do. Hit the math key. And down here at the 8th option is a numerical derivative. So select that. It should give you something like this. So that's d by dx. And, well, I want to differentiate 4 sine of x plus 1 over tangent of x. I don't really feel like typing that all in again. So do you remember the shortcut the other day? The vars key, then cursor to the right once to get y vars, and then press enter for function. So if you need to retrace my steps, they're down here. Let's press enter or type the number 1. That's the derivative of y1, and put in an x here. I'll want the derivative and the second derivative, so let's repeat that again. Let's go to the math key, math 8, derivative with respect to x. This time I want to do of y2, so we'll go to the vars, y vars, function, and then 2. And then again, plug in an x here. So this notation is saying where you're going to evaluate it at. You're really going to evaluate it at x. So everyone got in these two expressions. I want to make sure we're here. Is a good place to stop if you need some help. Sarah, doing okay? All right. Clyde, Krish, Zaid?
You get to y1.
Say again?
How do you get to like
the y1?
Yeah.
So to get to y1, you're going to go to the vars key, press the right arrow to get to y vars, press enter, and that'll give you your choice of whatever one you want. You could do y1 or y2, whatever you need. Okay? You're most welcome. So let's go back here. Let's see. Initially, maybe you don't want the graph of all these 3 functions at the same time, so slide over here, and on the equal sign, press enter. You can see the difference between y1 and y3. y1 is highlighted, y2 and y3 are not highlighted. That way when I graph this, I'm just going to get the graph of the function, not its first or second derivative. Let's go back and take a look at our window. The one adjustment that I might make is that a lot of times these interesting points are going to happen at, you know, pi over 2 or pi over 3 or pi over 6. So one clever thing you could do for yourself, I'm not sure it's really going to work for us much in this problem, you could do like pi divided by 2 to put, you know, better units or more useful units. I'm not sure it's really going to help us in this one or not, but let's take a look at the graph now. So, okay, it's not happening to land on a nice point. That's okay. If you want, you can go back and plug in units of 1 there for your x scale and y scale. I think I'm going to do that just to give myself a better sense of where things are at. So there we go. So it looks like you got a little max around here, a little min around here, a min, a max, etc. But it's tough to tell where these points are. How could you figure out where these points are? What's going to tell you the nature of a min or a max? The derivative, right? So let's actually move past this and look at the derivative. So I'm going to shut off the graph of the function. I don't want to get myself confused. and come down and turn on the graph of the derivative. So just press enter on y2, the equal sign for y2. When you're ready, press the graph key and bam. Well, that's giving me some interesting information. It's telling me where the function's positive and where it's negative, except I don't exactly know where it changes signs. So how do you find where it changes signs or could change signs? Well, I'm going to need to know the location of this point. To find that, I need to find the zeros. So hit the second key, then the trace key. There's a nice option there that should be standing out. You want to find where it's 0. It's going to ask you for a left bound of your point. So hit the cursor, hit the arrow to the left until you get past where you think that graph crosses the x-axis. That's going to be your left bound. Basically, you're telling your calculator, look here. You press enter, and then I ask you for a right bound. Well, you scooch past where the graph crosses the x-axis, and now that's your right bound. It's going to look for a root in here. Make sure your graph has a change of sign in that interval. Now it's asking you for one more thing. It's asking you for initial guess. Just press enter one more time. You should get about negative 1.297. Let me see a show of hands if you're able to get that point. All right. So somebody that can help out. Russell?
I don't know. I think it's just one calculator.
So you're going to hit the, oh, you got me, yeah, you got me, Inspire.
Yeah.
Yeah, sorry. You're always free to borrow one of mine.
Okay.
All right. Anyone else?
How do you turn off the other Y's again?
So you just come over here to the equal sign and press enter.
Oh, and it just turns it off?
Yeah, and it
Okay.
just shuts it off.
Okay. Like, my dogs are
Okay, you're graphing the second derivative. You want to graph the first derivative.
Yeah, but they're not looking into this.
Oh, that's because you have 1 minus tangent. You want 1 divided by tangent.
Okay. Thank you.
Yep. Anyone else? Okay. So I've got that point. I need another point. I need to know where this graph crosses the x-axis here as well. Those are going to give me some more points. So let's see if we can't find that one. So I'll go back here, second calc. Again, I want a 0. Let's try this again. I'm already to the left of my point, so that's great. I've got a left bound. Move to the right. Press enter to get a right bound. I've got a change of sign for the graph in between here, so press enter and you should get negative 0.577986, etc. Let's round that to the nearest thousandth. What would that be to the nearest thousandth? Negative 5.78. Negative 5.78. Now, I'm going to put that into our handout because we're going to fill out a little chart here for our handout. This is negative 0.578. Here was our first critical point. Even though 0 is not a critical point, it could change signs at 0. You do have to look for a change of sign because the function is actually undefined at that point. So we're going to do this as a little t-table for our derivative. Now let's see. I've got negative 1.297 and positive 1.297. I've got 0. I've got negative 0.578. Can anyone see another point that I can use here without necessarily having to go through that menu and do that calc part? Thank you. Thank you, ladies. 0.578. the derivative is 0 at all these points. 0, 0, 0, 0. In the middle, the derivative doesn't exist. That's okay. The function's not defined there. But how about filling in the signs of the rest of these things? Can we figure out what's going on with the rest of these things? Take a look at the graph of the derivative. This is the graph of y equals f prime right here. Is the derivative negative or positive to the left of negative 1.927? What's the sign of the derivative to the left of that point? It's negative. And then positive for a little bit, and then negative, positive, negative. And there's another little negative in here as well. Let's fill all those things in. Negative, positive, negative, negative, positive, negative. So if the function is decreasing, so it's decreasing here, and it's increasing here, what's that saying about this point here at negative 1.297? It's a minimum point. So that's a minimum point. Then it starts increasing, and it gets to here, and then it starts decreasing. So there's your maximum point. And these are local mins and local maxes. What's going on at 0? Well, it's decreasing. Actually, let's see, do I have this right? Yeah, derivative is negative there. So the function is decreasing, decreasing. Nothing interesting is happening here other than a vertical asymptote. But then the function starts increasing, so this point is again, well, this point over here is a minimum point, right? Decreasing, then increasing. Minimum point. Minimum point. And the last one, increasing to decreasing, that's going to be a maximum point. So you're going to get a lot of information just by looking at the graph of the derivative versus the graph. You can see a lot of these points. You can actually calculate exactly where these points are based on the graph of the first derivative. Let's come down here to work on the second derivative. Are we okay with the first derivative? For the second derivative, do we need to practice finding these points? Are you okay with finding where a graph crosses the x-axis? Thank you, Hannah. That's going to happen here at negative 0.8576. So the second derivative is going to be 0 there and there. But try and fill in the signs for the derivative and determine the concavity. Determine where is it concave up, where is it concave down. Determine positive and negative. Now, you don't have to worry about the function down here at 0. It's not defined there. The graph has a vertical asymptote at that point, so it's not in the domain. It can't be a critical point, can't be an inflection point. But try and determine the sign of the function in between these things based on the graph. Eyeball the graph. If you're watching this at home sometime in the future, then pause yourself. See if you can't fill in that chart. about concavity, not increasing. Okay, so let's see here. To the left of this point, and I'm presuming that that's going to be our negative 0.8576, negative 0.8576. To the left of that point, the function is positive. To the right of that point, but to the left of 0, the function is negative. To the right of 0, but to the left of this point, the function is positive, and then negative over here. So positive and then negative. Now remember, the second derivative talks about concavity. So what's the concavity for these things here? Faith?
Positive, or, whoa, okay, up, and down.
Nice. Let's see if that matches the graph. Up, down, and down. Looks pretty good. And you can fill in the intervals where it's concave up and concave down now that you've got this chart all filled in. But I guess the couple things that I want to make sure you're comfortable with are graphing these derivatives without necessarily calculate them, and finding where these graphs cross the x-axis. So are you okay with both parts of those things? Those are the things that I would expect. Now, don't always expect things. I mean, if we needed to, we could differentiate these. That's not a problem. But it gets a little messier here when you're talking about e to the arctan of x. You know, I don't think any of us really know the derivative of that off the top of their head. So, you know, you want to be able to do things numerically. So give that a shot. I'm going to cut things here and give you a chance to work on example C based on what we just did. Now you can use your calculator to graph these derivatives. The arctan of x, the way you plug that into your calculator would be x squared minus 49 times e to the tangent inverse of x. That's how you're going to do it on your graphing calculator. Your calculator doesn't have a key that's labeled arctan. It's labeled the inverse tangent. Make sure your calculator is in radian mode when you do these problems. Calculus is done in radians. Otherwise, there's this ugly factor of pi over 180 or 180 over pi that you're going to get in all your derivatives.